Hi, this is Caleb with MICROMINE here in the Denver office. I'd like to show you a feature of MICROMINE that you might find useful. All right, so we're going to talk a little bit about drill hole planning. So first, let's give this some context. So if we pull up a wireframe, I'm going to go ahead and pull in a DTM, this topo. So let's take a look. All right, here we are. So in order to give this a little bit more context, let's go ahead and put a image on there. So let's go ahead and drape an image. Pull on this one. It's already geo-referenced. All right. So here's where we're going to go drilling, but we don't want to drill just anywhere. We want to know what property we're drilling on. So let's go ahead and pull in a string file with our properties. Let me grab this property boundaries. I'm going to opt to make this line a little bit thicker and make it a little bit lighter as well. I also want to know which property is which I know in this file happens to be under this property. Make this a light color as well. And a little bit bigger. All right, there we go. So now we have some properties. Like everything, we should go ahead and save the form set. Saving a form set is always important. All right. I'm going to do the same thing with the topo. Okay, great. Oh, now we can see that this string is actually floating in space. So I'm going to go ahead and drape this on that wireframe. All right, great. So now we have a lot more context of what we're actually doing here. We're going to be interested in drilling in this C series of properties, both 13 and 89. So now that we have some context, let's actually go ahead and do some real drill hole planning. So the tools to do drill hole planning exist up here under drill hole planning. There's a number of different options here. So we have a bunch for different holes, and then we can also go ahead and do drill hole patterns. So let's do a drill hole pattern first, because we know that we're going to be doing some sort of scoping study. So if we do a drill hole pattern, we get this dialog that pops up. So the way that this is going to work is we actually are going to be creating a grid. All right. And if we look at this graphic of the grid, we can see that we start at an origin. And from that origin, we're going to have a bearing. So the bearing is going to tell us where the grid is actually going to get lined up with. And then of course there's a width and a length to that grid, relevant hole spacing and line spacing. And we can go back to this if we get confused. So we need to have an origin. So if I double click on top of this dialog, it'll disappear. And down here in the bottom right, you can see where we're located. So I would like to go ahead and have my origin about right here. So that is going to be 25083, 15755. All right, now we need a bearing. So in order to get a bearing, one really useful tool is going to be our ruler. So if we use our ruler, we can turn snapping on. And here we can see that our azimuth is around 281. So I'm going to put this bearing in of 281. We are going to only want to drill inside of these two locations. So therefore, we can just go ahead and make a restriction that will only be looking at those locations. So I'm going to make this width and length very big. My hole spacing, I'm going to go for 20. This will be whatever units you have nominated. So in my case, I happen to be in metric. And for the line spacing, I'm going to go ahead and put in 30. We need a hole azimuth. So I'm going to go ahead and put in 100. Obviously, this would be whatever you actually need. Do -75 and a hole depth of 100. Again, this is all just for an example. we can go ahead and designate what we want our z-values to be. We can either do this as a constant, or we have a DTM here, so let's just go ahead and take advantage. So I'm going to do it from the DTM. And we had used this before, this DTM, the topography one. We can go ahead and have these holes that are going to be named. So I'm going to do RC holes, because we're doing a scoping study. And I'm going to opt to number along the line. So what this means, if we go back to our diagram, from our origin, it's going to literally number along the line. So we do need to check that checkbox in order to make sure that's going to work. We could also increment the last numeric component. So if you have a little bit more complicated situation here in terms of your numbering, you could have it say another number on the end, and it will number the last numeric component like this. And if you uncheck it, it'll label the first one. We don't have that here, so I'm just going to go ahead and take that off. We do want to restrict by a polygon. Here we already have the string file here, so we know what we're looking at. So let's go ahead and say we want to restrict by polygon. We want a string file. This is our properties. Find a string file. But we only want to restrict by these two. So I'm going to opt to turn on a filter. And I want to filter on property. I want this to be equal to C11. I'm going to go ahead and put a star in here. This is a wildcard. This is a function of all filters in MICROMINE. Filters are very useful, and I use them all the time, and I'm sure you will too. This means that anything with C11 and after will be filtered out. I'm going to save that filter, and then go ahead and take a quick look at my file to make sure it's working. Here we can see in gray, this S series is all getting filtered out. We zoom down, we can see the C series is not. If something is gray, it's filtered out. If it's not, it'll be left in. We need to designate an output file. So this is going to be my planned RC drilling. All right. And there is the option here to go ahead and send this straight to a Drillhole database if we wanted to, or create interval files as we create this Drillhole pattern. But it's not necessarily needed, and we're not going to do it here just so we can see a couple more features. If we run this and take a look at this file, all right, here's a bunch of drill holes, northings, eastings, RLs, dip, azimuth, all the things that we're looking for. Great. So let's go ahead and actually put this in context. So I'm going to go ahead and create a Drillhole database. So a Drillhole database in MICROMINE is a way of pulling files together so you know that you can look at them as traces, meaning you have things like collars, surveys, interval files, any sort of event file, packages them all together so they're going to work together. So I'm going to go up to Drillhole, database, create, and this is my planned RRC drilling. Okay. The collar file is what we just created. Planned RRC drilling. And this is all we actually have here because all we have are collars. In here we have azimuth and dips and total depths. So we don't have survey files. Great. Now that we've done this, we can take advantage of our Drillhole trace function, select the correct database, which we just created. I'm going to opt to make these a little bit thicker in a different color. I'm going to put a hole name, but this is light gray. Change this so it's a little bit bigger. Hopefully not too big, we'll find out. And go ahead and show the collar. Lots of different options. I'm going to choose this target. Also make this a little bit bigger. Okay, let's see what we have. All right, so here's a bunch of new drill holes. You can see they have been restricted to the polygons that we want. Obviously, how this is displayed is fully customizable. I'm going to go ahead and save my form, as you should save all forms. It'll make less work and make it easier to see what everybody else has done. Great. Now, if we went ahead and took a side view of this, we can see here, if we spin this around, that these are at that 75-degree angle, and they are going to scale based on the DTM. All right, so we've gone ahead and made our drill holes. If we go ahead and cut a section here, we can get a good profile view. So I'm going to change my drawing style of this wireframe to auto, which is going to get and give me this nice 2D slice. If I want to go ahead and go to a particular section, which I do in this case, I can go to my section control file and pull up the exact one that I want. Now, when we do this initial drilling, perhaps we run into something more interesting. So let me pull in some potential interpretations that I made for us. So I'm going to pull in this vein interpretation. I'm going to color some polygons. Make sure everything else is turned off. All right, great. Magically veins appear. Wouldn't it be great if that happened in real life? So we do know that we want to investigate these a little bit further. It's what we ran into with our RC drilling. So let's create some individual, deeper drill holes. So maybe we want to do some diamond drilling to get a better idea of what's going on. See some structures in there. Under drilling, planning, we have a number of different ways that we can go ahead and put in a diamond drill hole, or any sort of drill hole. All of these are actually going to be strings when they're created. So I'm going to go ahead and create a particular string file that I think will be useful, although any string file would work. So if I go up here to New, String, down here, and change some of its properties, I would like to go ahead and label, show label from a field, and this will be based off string. That means that any string that I create, whatever I label the string as, drill hole 1, drill hole 2, drill hole 3, will get displayed. And I want to show it as my first label. I want to label some things in the segments. I want the bearing, the inclination, and the length. These are all obviously useful things for drilling. I'm going to go ahead and put in decimals of 0, just because we're doing this as perspective drilling. And I'm going to put it on the segment. All right. Okay, I'm going to save this. It's our planned diamond drill hole drilling. And then I'm going to save the form set as well. All right, great. So if we go ahead and put in our first diamond drill hole, I'm gonna go to drilling, planning. We can go from the collar. We can also go from the target. We can do straight, we can do curved. I'll just go through them in sequence here. I'm gonna go from collar, straight. If we turn on and off snapping, it'll make it easier to get it to go exactly where we want on the surface. So I'm gonna snap it here. You can see it says design straight drill hole from collar. I'm going to opt for this one to be 100 long, an azimuth of 280, and inclination of -75. I'm going to have a azimuth on here that'll keep on section. That's the only reason I'm doing that. And then you can go ahead and add segment. All right? You could add another segment if you want to. You can go ahead and undo. Here we can see that this drill hole now is labeled, that we know it's an azimuth of 280, -75 dip, and it's 100 feet deep. Quite convenient. We can also see the label for the drill hole up top. If we go into the string settings, we can go ahead and just change the name of that drill hole. All right, and here we have our first drill hole, DDH001. Because I created those particular settings in the string, it's going to make things a little bit easier to see. Not necessary, but something nice to do. Now let's go ahead and create one with the drill hole planning curved. All right. This segment length we're going to do as something shorter, 20. gonna put an azimuth of 100. It's gonna be -90. All right, and now we can show a rate of deviation. So each individual segment can have a different rate of deviation. So here, I'm not gonna change the azimuth, I'm gonna change 2 degrees per segment, so my segment was 20. We can opt to do this interactively, meaning when I go ahead and click and hit Add Segment, this is gonna be an interactive style because I'm adding each segment. We can see it curve here. Each individual segment, the way that I have it set up, you can see how the dip is going to change, and the azimuth, if you have that changed on a rate of deviation. You could opt to do a total number of segments or a total length if you like. I'm just choosing not to do that here. All right, so there's our drill hole. No different from the last one. I'm gonna go ahead and have this one be DDH002. We have our second drill hole. Moving on, we can go from target, meaning we're going from the bottom. So maybe I click here. I can opt to either have a total drill length or I can extend to the DTM. So in this case, I'm just gonna extend to the DTM. We have one here. DTM, this is our topo. For our azimuth, I'm gonna do 100, 90. You can opt to reverse the string, meaning you drill from the top or you drill from the bottom. The string isn't gonna be able to tell that, but you can say that you wanna reverse it because I'm going from the bottom to the top. You could opt to extend beyond the target too, if you like. All right, I hit Add Segment, and it shoots it and snaps it right up to the surface. Here we can see it's a little bit busy here. This is one of those times that it's quite convenient, that these are just strings, because I can just go ahead and say, a little bit too busy, I'm gonna drag this over. Maybe I wanna turn on snapping, snap to my line, come up here and make sure that this is gonna snap. All right. This is gonna be DDH003. Okay, we can also do curved from bottom, drill hole planning, curved. Great, here we go. Segment length, I'm just gonna go ahead and do 25 this time. Azimuth of 280, 85, 0, and 1.5. I'm gonna do it interactive again. This time I am not going to extend to the DTM. I'm going to opt to do this myself. Same options as other drill holes here. When I go ahead and start adding segments, we can see that it goes beyond the surface. All right, I'm gonna move it over again. It's a little bit busy, but this time, clearly I have a problem. Both I have the name of the hole is at the bottom, so I could just right click on this string and go ahead and reverse it. I also need to go ahead and just clip it to the surface. All right. Diamond drill hole 4. Great. There's a few other functions that are going to be useful here. Imagine you want to go ahead and extend your drill hole. You could click any one of these strings and just go up to drill hole, planning, extend your drill hole. I could say that I want another segment. This is going to be how much it deviates from the last one. So clearly this would be quite dramatic. So I'll just keep this straight and add another segment. No problem. Maybe we have a bunch of different drill holes and we know that they're all going to drift in the same way. We could just go ahead and select one of these drill holes and just copy it over. All right, quite convenient. Snap to surface. Oh, I didn't hold control there. Let's do another one. There we go. Snap to surface, no problem. Label this one number 5. Okay. And that's about it. Now we have a bunch of different drill holes. These are all strings. So clearly we need to do something other than have them just be strings. And we can do this here through drill hole planning, create collar and survey files. Right? Let's make sure we go ahead over here and save this file first so that it captures all those drill holes that we just made. To drill hole planning, I'm going to create collar and survey files. I have my trace. These were a string. my diamond drill hole collar, diamond drill hole survey. These are both planned. You could opt to auto reverse when the Z is going to be deeper than the end of the hole. All right, and go ahead and run that. Great. And now we could opt to just add this to another drill hole database. I'm going to create a separate one to keep things clean, and we can see how this is done again. So we can go to drill hole database. Great. This is going to be my planned diamond drill hole. Oh, let's go ahead and do that again. Great. Database, great. Diamond drill hole drilling. Grab our collar file. Grab our downhole survey file. All right. And now we can go ahead and add those traces just like we did last time. We've created another drill hole database, packaged everything together. Grab the correct input file now, or input database that is. And take a look. Now we have a bunch of drill holes. And that's it. So hopefully you found this useful. And those are the basics of how we deal with drill holes here in MICROMINE.